very important concept is odd days. Number of days exceeding the complete number of weeks in a given are called odd days for the duration. Suppose we have ordinary years and leap years. In an ordinary year, we have 365 days, and in a leap year, we have 366 days. Further, applying this definition of odd days, complete number of weeks are, and then this day is exceeding. The number of days exceeding the complete number of weeks in the given duration are called the odd days. So one odd day. Here we have two odd days. We'll have Monday, and their odd days. 3 days, 0 or 7, 1. 4, 5, and 6. This will follow. So there is a remark or note. Any century year ending with zeros will not be called a leap year if it is not divisible by 400. Any century year ending with zeros will not be called a leap year if it is not divisible by 400. So, year 100, 200, 300, 500, 700, 900, and similarly 1800, 1900 were not the leap years. Now, calculations or counting of odd days. For the first 100 years, there were 24 leap years and 76 ordinary years. Because 100th year was not the leap year because it is not divisible by 400. So there were 24 leap years and 76 odd days. Every leap year has 2 odd days. So 48 odd days, and every odd day has one odd day, 76. Now this comes to 124, and this is 17 complete weeks plus 5 odd days. So for the first 100 years, 5 odd days. Similarly, we can find out for first 200 years, 300 years, and 400 years that the odd days were 3 odd days, 1 odd day, and no odd day. Means 0 odd day. So after every 400 years, the day repeats. The same day repeats. Odd day 0 means. So suppose first day of a month is Sunday, then after 7 days, 8th will also be Sunday because the difference is 7. So number of odd days is 0, and then same day after that 7th day 8 they will repeat the same day. So difference is 7. Counting the odd days for months. For January, it is 31 days, so 3 odd days. February, when there are 28 days, and when there are 29 days. So 0 odd day, 1 odd day. March, again 31 days, 3 odd days. 7 into 4, 4 complete weeks plus 3 odd days. April, 2 odd days. May, 31, 3 odd days. June, 2 odd days. July, 3 odd days. August, 3 odd days. September, 2 odd days. October, 3 odd days. November, 2 odd days. December, 3 odd days. So we have odd days for months. Now how to use these all data we collected just now? Suppose we want to find the day of the week on 15th of August. So what do we have to use? We have to simplify this data. Like 1946 years have passed, 47th is running. So in these 1946 years, what is the breakup? So multiple of 400 means 1600 is the nearest one, which will give us 0 odd days. Then 300 years, we just calculated 1 odd day. Now 46 years, 11 leap years, and 35 ordinary years. Every leap year has got 2 odd days, 1 odd day. So here 58, the sum is 58. Now, second thing, year 1947, which is not completed, which is from 1st Jan to 15th of August. Now odd days for this year. This is an order year. We will consider 28 days for February. So for January it is 3, February 0, March, April, May, June, July, and August 15 days. So odd days 31, 58 and 31. So we have 89 days, odd days. Further, 12 weeks plus 5 odd days. And 5 odd days for Friday. So it was Friday on 15th of August 1947. Now, which 2 months have same calendar in an ordinary year? First day of those months should be same. Now, in 3 odd days, 0 odd day, 3, 2, 3, 2, 3, 3, 2, 3, 2, 3. Now, with Jan, which next month will follow the same calendar as of Jan. 3, 6, 8, 11, 13, 16, 19, 21. So here we have 0 odd days. So October will start the same as Jan. Similarly for Feb, 0 odd days. So Feb and March will be same. For March or Feb, further 3, 5, 8, 10, 13, 16, 18, 21, November. So Feb and November and March and November will be same. So this way we can find out all other months. Also in leap years also. Similarly, the same thing we can apply for same calendar years. Clocks. Some concepts, clocks, you need to remember. Hour hand and minute hand coincide is one over the other. 11 times in 12 hours. Another information is these two hands, the hour hand and minute hand. I'm highlighting this, and minute hand are opposite to each other 11 times in 12 hours. The hour hand and minute hand are perpendicular to each other 22 times 12 hours. Suppose this is a clock. Now, we can see that at this point, minute hand and hour hand are coinciding with each other. Now, hour hand goes from here to here. Minute hand takes 60 minutes to reach 12 again. But in those 60 minutes, iron will move only 5 minute spaces. So iron goes 5 minute spaces. 5 minutes spaces in 60 minutes. While minute hand goes 60 minute spaces in 60 minutes. So clearly, minute hand gains 55 minutes or hour hand in 60 minutes. So minute hand is gaining 55 minutes in an hour every time. Let's start with one question. At what time between was 4 and 5 the hands of the clock coincide each other, and third perpendicular to each other. To each other. Now first coincide. Now it's 4 and 5. So suppose at 4 o'clock, R hand is here and minute hand is here. So this minute hand has to travel or gain 20 minutes in order to overlap or coincide with R hand. So minute hand gains 55 minutes over R hand in 60 minutes. It will gain 20 minutes, 21 and by 11 past 4 will be the time the two hands will coincide with each other, or they coincide with each other daily. Second sum, opposite to each other. Now for minute hand and opposite and this R hand to be opposite, they need to be at an angle of 180 degrees with each other. In a clock, it is generally this half side of the clock, or you can say 30-minute spaces. At 4 o'clock, minute hand is here. It has to gain 50 minutes or R hand to be exactly opposite to each other. We are talking about the relative motion. So we have already taken the gains. So it has to gain 50 minutes (54) 6 by 11 minutes past 4. They are opposite to each other. Now third one is perpendicular to each other. Now here we can see they can be perpendicular to each other in two directions. One is in this direction, because if we fix this R and needle, we find that this will be the exact perpendicular to this, and at the same time in the different direction it will be 7. So two cases we have to consider. Case 1, so minute hand has to gain 5 minute spaces over R hand in order to be perpendicular to R hand. So at 5 by 11 minutes past 4, the two hands will be perpendicular for the first time at 4 and 5, between 4 and 5. Case 2, when minute hand is here, so it has to gain 35 minutes. So we can consider this case here only. Case 2. (38) 2 by 11 minutes past 4. So there are two cases for perpendicular. Now the angles between two hands. You want to find out the angle between the two hands at 740. First we'll find out the movement of the two hands, R hand and minute hand. We have 12 intervals and total angle is 360 degrees. So one interval of 30 degrees. One interval is of 30 degrees. And Rn goes 30 degrees in 60 minutes. Because it goes 5 minute spaces. that is 30 degrees in 1 hour or 60 minutes. So the movement of R hand is half degree in 1 minute. And similarly, minute hand goes 360 degrees in 60 minutes, that is 6 degrees in a minute. So clearly we can find out minute hand gains 5.5 degrees over R hand. So in this case, at 7:20, we need to find out this angle. Now, if we fix these two hands, we can outrightly say the angle is 90 degrees because three spaces of 30 degrees each. But in 20 minutes, minute hand moves from here to here. At the same time, R hand is also moving in this direction, clockwise. So in 20 minutes, R hand goes 10 degrees. Half degree in 1 minute, 10 degrees in 20 minutes. So this space is here. So this angle will be this angle. The true angle is this. That is 90 plus 10 degrees. So we can say that at 7:20, angle is 100 degrees between R and minute hand.